We'll do a really simple example here. I'm just going to start with a sphere, go inside and make that a polygon, frequency at 10. What I'm going to do is scatter some points here on the sphere. And this time I'm going to turn off relax iterations, and we'll do something like 600. We will use an attribute VOP here, or attribute wrangle rather. And we're just going to assign some random p-scale values to that sphere. So we'll say f at p-scale is going to equal fit 01 rand attribute point number between, let's say, 0.02 and 0.1. I don't know if these values are going to work for us. We'll have to see in a second. I'm just going to take a sphere and we'll copy that. Not a bad first guess. Okay. So I'm going to try to do one step here to resolve some penetrations. I'm just going to do a point relax, and we'll just plug that in here, and I think that is for our reference surface, which I'll plug right into the sphere here. And that should do a pretty decent job of trying to make sure that these spheres are not intersecting each other. And maybe if we wanted to go even a little bit smaller, we could do something similar to that. Maybe pack even some more in here. Why don't we go to 900? All right, so we've got some kind of random stuff going on here. I'm going to assign some random colors as well. So why don't we choose a color, and we'll just choose random here. And all right, that looks good. So what I'm doing is just testing kind of how our points are going to be distributed along the sphere, and just kind of seeing what we get out of it here. All right. So we will set this up for a render. I'm just going to grab an area light and position it maybe kind of a little overhead here. I'll lay down a camera, look through the camera, and then zoom out so the sphere is in focus. I'm going to go to my output tab and put down a mantra ROP. And that should be enough for us to start with. We'll go ahead and save this file, and then we'll continue working. What I'd like to do is take the color information from this point cloud, as well as the p-scale attribute, and use that in a shader that we can use to influence the rendering of this sphere here. But one thing to know is that shaders cannot access what is in the Houdini scene, because Mantra just doesn't have access to your Houdini file. It actually has access only to these external IFD files that are written. So any point cloud that we want to access in a shader, we actually have to write out to disk first. So we will just use a file cache to do that. I'm just going to plug that right in, and we will choose save current frame. And this is fine here, and I will just call this point cloud. And just choose save to disk, and that should be in there. Now I'm going to make sure that our sphere is visible. We'll go to our material palette. I'm going to drag a principled shader out here, and then I'm just going to drag the principled shader onto our sphere. If we go into our matte context, we should see now that we have a principled shader, and we have our sphere here, and we're just going to go into our render view, and I'm going to click render, and that's going to start a render. Okay, there we go. So let's start using our point cloud. And what we'll do is we'll grab the color information from that point cloud and we will apply it to the sphere. So what we want to do is take the surface here, and we have base color, and we want to replace this with the colors from our point cloud. So to do this, we of course need a point cloud open, and then we'll use a point cloud filter, and we'll only grab one point. I can just plug the handle straight in here. Radius, we will just keep our radius at something quite large, and we'll see maybe like 1, number of points to 1. Now we have to get position. So I need to get our global position. So I'm typing global variables. I'm just going to choose output a single variable, and that's position here. But one thing to know is that position here is in shader space, or I think camera space, one or the other. But it's not actually in the world space, or the object space rather, that those points were written out in. So we actually need to transform this space. So if I start typing transform, you see we have a bunch of them here. I want to grab that top one. Oh, no, we don't want to grab the top one. Let's try the middle one. And nope, we want the bottom one. Finally. Okay, so we got the bottom one. And we want our position going into from, and we can just keep that just like that is here. Now that position is actually going to go into our PC open. In PC filter, we want to grab our color channel. And we're going to take that value and go right into base color. Now I'm taking a snapshot of what this used to look like, and I'm going to click render again. And then we have one problem because I haven't actually told it where that file is. So we need to go into our HIP here, go to the geo, and go grab our point cloud. Click accept, and there we go. Now we can see that it's actually sampling those points. And that's really cool because we get a really high resolution sample because we're actually sampling for every little small sample on the pixel, on the image plane that it's doing. And I actually think it's sub-pixel sampling based on what's here. But we can do a little bit more than this as well. We can run this into displacement. So I'm just copying, pasting, and now I want to change this to float and grab our p-scale attribute. And maybe I can set this p-scale attribute into our displacement value here. I'm going to go on to displacement here and choose enable input displacement. And now we're getting displacement based on that p-scale value. That's really cool. So let's go ahead and stop that for a second. And let's see what else we can do here. We know that we have our current lookup position and we have the retrieved lookup position if we want. So why don't I go ahead and grab that as well. And maybe we can modify what's happening with the displacement based on our distance from our lookup position or from the actual point position. So let's go ahead and take a distance here, and we will measure the sample distance from the actual distance of the point that was written here. And then we will fit that. So now we will say as our distance goes from 0 to our p-scale value, we are going to use that as our new displacement. And I'm going to say our maximum displacement here is something like 0.1, just as a guess. Now we'll go ahead and click render again. Well, that's pretty cool. Why don't we reverse this? So let's go ahead and say 0.1 to 0. And I think I need to re-click that. So that's pretty cool. We're getting these cool little spikes, and they are working exactly in those little patches, just like we would expect. And we've got something that looks very similar to some of those magnetic fluid videos and stuff that are kind of out there on the web. And we can do that all here at render time in displacement just by referencing point clouds. And we could have moving point clouds and whatever it is that we want and still get all this kind of stuff. So that is really, really cool. And if we wanted to as well, we could just go ahead and why don't we just add another little light just so that we can see everything. Just adding an environment light, turning the intensity down to something like 0.25, going back to our render view and taking a quick look. Now this is going to be kind of a bit slower of a render, but that's okay. And then the other thing that we could do here, I'm just going to hit X to stop that. Why don't we fit this like that, or even do this? Why don't we say our destination goes from 0 to 1. That's fine. And let's make some space here. Now let's run that through a ramp. Only change this to a spline ramp. Run that right in. Run that right in here. And then let's multiply that by some parameter here, which we know is going to be our displacement here. I'm just going to call that disp. So this will be our maximum displacement. So why don't we say 0.1? And now we could do this where we know that we wanted this to be 1, and we were going to want this to be 0. But in between, we can go ahead and do some kinds of crazier stuff, and maybe we'll smooth this stuff out by going with this monotone cubic interpretation here. All right, now let's take a look at what that looks like. And, oh, that's why that shouldn't be doing that. So float range there, and it's the default. That's what we wanted, 0.1. So we just had the wrong thing plugged in. And now we can go up maybe even higher. Oh, let me just dial this down. I think we need to actually re-render here because it needs to recalculate our displacements. So it's not actually aware that the displacement has really changed. So it kind of bakes it in. You can see now that's too high. I wanted it really here at 0.1. I'm just going to click re-render. And to make this even faster, what we'll do is we'll just isolate a small section here. So that's pretty cool. I'm just going to maybe take this down. Why don't we maybe give ourselves like a nice little thing like that, and maybe just spike it up just a teeny little bit down here at the end. And we'll just click render one more time. We'll just look at about the top half of this. So this is a really cool technique because we are doing all of this stuff here at render time, and we're using point clouds, and we're doing all kinds of crazy things that would be difficult to do at a very, very high resolution with actual geometry. But we're using point clouds, and we're influencing the way that it actually renders this geometry. Very cool, very interesting in terms of the amount of possibilities and things that are out there that you can do once you start to work with point clouds in the shader context. So just for fun, I did a couple more tweaks on here. I just went into the environment light and added an environment map. And then I went into the matte here and multiplied back by the p-scale parameter so that I could have various displacement levels on here, and then just changed our displacement all the way up to 2. And yeah, that's it. So hope you enjoyed that little lesson there.